Assalamu alaikum. Right. So we're gonna discuss in this question, and this is one of the past paper question, or you can say that by doing this one, you can easily find out the amplitude, you can easily find out the period, frequency, angular frequency, spring constant, and speed at specific time. You can also find out the acceleration at specific time, speed at specific time, right? Displacement, velocity, and we can also sketch a velocity time graph by looking at this given displacement time graph, right? We can also sketch the acceleration time graph. We can also, sketch the displacement versus time if there's no friction. So, in today's class, we're going to discuss these all factors by having only this displacement time graph, right?
Okay.
So, the very first thing that comes is the part A says to find out the amplitude. So, as we know that amplitude is the maximum displacement, right? From the mean position or from the equilibrium or reference line. So this horizontal line shows the reference line or a baseline. From here, whatever the distance that is covered to the peak, okay, is going to be a
Okay.
amplitude, right? So the amplitude
Yes,
of
sir.
this is going to be 0.15, right?
Yeah.
0.15.
Let me just
Yeah.
double check, sir. Yeah, okay. 0.15. Yeah.
And this graph can be, can also be considered as an example of the object performing the simple harmonic motion, right? So
Yes, sir.
I have if I am saying the amplitude is 0.15, so this means the spring which is connected with a fixed support, initially it was at x equal to 0, right? When you stretch it, the force is stored in it, the maximum point till you stretch it. So that's going to be the 0.15 meter. Okay, clear? This is
Okay.
how you state the amplitude in this system, 0.15 meter, right? So that's how the amplitude is considered from the mean position. Okay. Uh,
Okay, sir.
when we Then we talk about the period. How will you find the period? Since we know that period is the time taken by the one wave, right?
Yes,
So
sir.
I told you how to count the number of waves, okay, or how will you consider a one wave? So from one peak to another peak, you will consider the one wave completion here, or you can say from this trough to another trough, the distance between them is going to be one wave, right? Or you
Yeah,
can
you
call
explained
from
this to
here.
me last class.
Yeah. So you can also consider from this point, I'm calling it P, and then you can end your first wave at Q, right? So considering this region, that is the trough, and this that's a peak or a crest. So considering this trough and that peak or crest will give you one wave, right? So
Yes, sir.
the one wave time, since on the x-axis we can see there's a time given here, right? So the time for the one wave, if I am starting from here from point A, so I have to end at point B. So what is the time between these 2 points on the x-axis? What is the time here for this wave to complete one wave between A and B?
Isn't it two?
Yeah, it is 2 seconds, okay?
Yeah.
Now we're gonna talk about another thing. You have to, recall the equation for the x, right? The displacement equation. It is
Mm,
x cos,
okay.
we did this, right? X cos omega t. And where omega is 2 pi f, right? In one of the classes, I explained this, right? We did this before.
Yeah, I think it was last week, sir.
Yeah. So we're gonna talk about the frequency now. The part C is asking to calculate frequency. So frequency, how will you find it? It's yesterday even I was explaining about the frequency. So if you are considering one wave, so you're gonna divide that one wave by its time. So it's going to be 2 seconds, right? So the frequency is going to be 0.5 cycle per second, right? Either
So
you
is cycle per second
or
the
you
unit?
can call it hertz.
So
Okay.
if I use cycle per second, it's also permitted, right?
Cycle per second is the bigger unit, right? And hertz can also be used. Okay, clear?
So is it preferred to use cycle per second or hertz?
Actually, the SI system says it's hertz, right?
Okay.
Now we're gonna talk about the angular frequency. Angular frequency. So the angular frequency is going to be omega, right? And the omega is equals to
Yes.
2 pi f. So you just plug the value. Mm, 0, okay, 1/2, right? So 2 times 2, it's cancelled. Pi, that's going to be 3.142, I think. Yeah. Or you call it pi radian per second. Remember
So three
the
point
unit?
one four two is pi's value, right?
Yeah, 3.142. Or you
Okay.
can leave the answer in pi. So pi radian per second should be the unit. Radian per second should be the unit of angular frequency. Now we're
Okay,
going to
sir.
talk about uh, spring constant. You remember how to find out the spring constant?
Uh, Let me just look through my notes. I think I wrote it down.
See, it's going to be your spring, right? The
F
question
is
is,
equal to minus kx.
okay, I even explained to you yesterday, k equals to f upon x, right?
Okay, okay. So k is a spring constant, and F is a restoring force,
Yeah,
and x is the displacement from equilibrium, right?
exactly. Okay.
Okay.
So we are going to use the formula for that. Uh,
Okay.
since we do not have the force, so what we can use instead using k equals to f upon x, we have the mass, right? So what we are going to do is, since we know the mass of in the question is 2 kilogram, that is actually given, but I have already taken the graph from this question, right, from the past paper. So the mass is 2 kilogram, and we gonna find out this spring constant, which is K, right? So we can use this formula for the spring uh, performing simple harmonic motion. So the time period is 2 pi under root m upon k, where we know that time period of this system is 2 seconds, right? Do we know this? That's going to be 2
Yes, sir.
seconds. And that's going to be 2 pi. Okay, and we know this 2 kilogram divided by k is unknown, right? So what we can do now, we are going to make uh, this k subject, right? So this 2 and 2 gets cancelled. So we are left with 1 equals to pi under root 2 over k. Now for making this k subject, we have to put the square root, a square on both sides. So squaring on both sides, we get 1 square equals to pi under root 2 upon m whole square, right? And
Yes, sir.
then 1 square is going to be 1. Pi square is going to be pi square times this root gets cancelled with the square, so we're gonna have 2, and then we're gonna have m. Right now, oh sorry, not m, it's k in the denominator, right? Now we're gonna shift this k over there from denominator
Okay.
to the left hand side. So it
Sir,
will
can you send
be,
the recording of this presentation too
yeah,
on the WhatsApp group?
it is always sent, okay? So k
Okay.
equals to 2 pi square. So what is the value, if you can plug the value in the calculator? Tell me the value.
Yeah, hold on. Sir, 19.739.
19.7, okay. So 19.7 Newton upon meter.
Yeah.
The next is, after solving the spring constant, we're gonna have a speed at 1 second. Speed at 1 second. We have to find out the speed at 1 second. Okay. Part E, F part A says speed at 1 seconds, right? Now, what we know that this graph, which is, Mustafa, are you not connected? I think Mustafa Ghani. Okay. So if we look at the graph, so we'll see that the one at 1 second, the graph is at the maximum point, right? But below the x-axis. So
Okay.
this shows that the spring is completely compressed, right? It is compressed.
Yes, sir.
Okay. So if I draw it, the spring is like this here. Okay. When you stretch it, so this is going to be your maximum point, right? X is going to be max here, where the V becomes 0. Okay. When you say okay, so that's how the distance is covered, 0.15, right? That is the maximum displacement, right? Now from
Yes, sir.
when the this means In the graph, this means the graph is there, right? At this point.
Yes, sir.
At this point, let's say this is uh, point P. So we're gonna call it point P here, and the distance, the graph has now here from the reference line. Let me draw the reference line here. So the distance is going to be 0.15. Okay, and this distance is from the equilibrium point, which is 0.15, and we took from the graph, right? Now
Yes, sir.
the same distance is going to be below the x-axis. So that means that the object is not, this time the object is not at the right side, it is at the left hand side of the equilibrium position. So we're going to have the same distance on the opposite side, and that's going to be 0.15. Okay, right? So at this point, when the object reaches at this point, so it is completely compressed, right? It is completely
Yes, sir.
compressed, where it will have the speed 0, right? Okay.
Yeah.
So the speed at 1 second, since the 1 second in the graph, we can see the spring gets completely compressed. And if we make a model of the spring, so we have this where the spring is here. Let me draw it. The spring is here at point Q, let's say at point Q, right? Now the speed is 0. So I hope this point is clear. The speed is going to be
Yes,
0.
sir, it is.
What if what if they ask the speed at 2 seconds? So again, you will say the speed will be 0 at this point. Why? Because it is at a maximum point. Okay. So
Okay.
at 2 seconds, the speed will again become 0, right?
Yes, sir.
Now after that we have um, acceleration at 1 second. You remember that we discussed the max and mins in the max and mins class, right? So in the part G, we're gonna find out acceleration at 1 second, right?
Okay. By the way, sir, do we have double class today?
Inshallah, right? We will have the
Okay.
maths class as well. Inshallah, I'll try to complete the logarithms today.
Okay.
Acceleration at 1 second. What we know that at 1 second the spring is completely compressed, right? From the graph you can see the spring is at maximum point, right? At extreme points.
Yes, sir.
Okay. So from the equilibrium position. So what we know is uh, um, how will we find the magnitude of the acceleration? So we have to, consider the sum of the forces. You remember I even explained you in the case of the pendulum, where the upward force, that is attention towards the support, and the downward is the weight. Okay. But yes, there's a little bit force acting on it at the equilibrium point, right? But at the extreme
Yes,
point, the
sir.
force and the acceleration is also maximum. Why? Because the spring is being pulled towards the equilibrium position. Therefore, the force is going to be maximum. So what we can write it
Okay.
here, the sum of the forces, right? Sum of the forces, if we consider that is the net force, okay? The spring force is there, so we're gonna call it MA, F is equals to MA, right? Now
Yes, sir.
what we know that F equals to KX for the spring, yeah. So since it is a restoring force, is it a restoring force? So we're gonna plug minus kx, and over here on the right hand side is going to be ma. Since we know that F is equals to ma from the Newton's second law of motion, and F is equals to k
Yes, sir.
from the Hooke's law, F is equals to k.
Yes, sir.
So we're gonna, compare them, and now we have this value of k as well. Yeah, we have already found out. Yeah, in the
Yes,
part
sir.
E, we have this value. And now what distance that we have here, we are going to consider that as well, right?
Okay.
So what if I make A subject, because we are working for acceleration. So I'm going to put k here. In the denominator, the m is there, the x is there, and this is how we're gonna find out the acceleration, right? So acceleration
Yes,
equals
sir.
to minus of k. What is the value of k? 19.7, right?
Yes, sir.
Times x. Uh, how much distance the body has covered at 1 second? At 1 second, is it at maximum point?
Yeah.
If you can see here, let me remove this. Yeah, at 1 second, where the graph is at the maximum.
Compressed point.
Yeah, it is maximum, maximum point or extreme point, or it is compressed completely. So this means that how far it is from the equilibrium point. How far it is from the equilibrium point? It is 0
Um,
0.15, right? It is
yes, sir.
0.15. You know,
So isn't it negative 0.15?
yeah, yeah, we are going to take that negative, right? So that's going to be negative 0.15, okay? And now we are
Okay.
going to divide it by which number? M, right? So M was
Yeah.
2.0 kilogram, right? Okay. Now we're gonna divide. First, you to multiply these
Sir,
two
I got
numbers. What answer you
uh
get?
negative 57 over 40.
How can you get this negative? Because this two negatives are there, so they will definitely become positive.
Okay, wait, let me do it again. 19.7 times negative 0.15 divided by. So I'm getting an error.
Let me do it myself. You can't get error.
Okay, never mind. I got 1.4775.
1 point.
1.4775.
Okay, so can it be 1.48, right?
Yeah.
Meter per second square should be the unit of acceleration. I hope this is clear now.
Yes, sir, it is.
Now we're gonna move to part GH, right? In part H, they're asking speed at 2.5 seconds. Speed at 2.5 seconds. Yes,
So we're
2.5
gonna do the
seconds.
same thing except we're gonna do the same thing except the numbers will be changed.
Yes. So speed at 2.5 seconds, if you can refer this graph again, they are asking about this point. So is it a maximum point or is a graph? Okay. Now looking at the graph at 2.5 seconds, is it at maximum displacement?
Oh yeah?
How can it be at maximum displacement? Is this a maximum displacement? Yes or not? This is the maximum displacement. This distance, this vertical distance is the maximum displacement. Okay. How can you say this
Okay.
point, at this point, the graph is at maximum point?
So isn't that going up too?
Can you please observe the graph? What is happening at 2.5 seconds? What is happening here? How the
It's
spring,
going down
is it going down or is it at, at this reference line?
at reference line.
Yes, so reference lines means that it is the spring. If we compare this graph with the spring, position of the spring or the mass attached with the spring, so that means it is the equilibrium point.
Yeah.
So where the x equal to 0, clear?
Yeah.
And here the x equals to negative 0.15. Here the
Yes, sir.
x is going to be 0.15.
Yeah.
Clear? Is this clear now? At
Yes,
2.5
sir.
second, the x is going to be 0, right?
Yes.
Now they are asking about which quantity speed at 2.5 seconds, right? So what we know that one, the speed, how will we find the speed, okay, at this point? First of all, you remember the formula that I discussed with you to find out the potential energy, half kx square, potential energy of the spring.
Yes, sir.
Okay, let me, you can refer the previous lesson, okay, and the formula for the kinetic energy maximum, we're gonna use half mv square, right? For kinetic energy
Yes,
maximum,
sir.
we use half mv square, right? And for the potential energy of the spring, potential energy of the spring, the US, right? Potential energy of the spring, you find out using half kx square, right? Okay, where x is the distance from the mean point, right? Okay. Now there's a law of
Yes,
conservation
sir.
of energy. One energy is is converted to another form of energy. Okay. So what we are going to do is
Okay.
the maximum at uh at the spring is at x equal to 0, right? 2.5 seconds. But it is not, at rest. It keeps going on, right? Just keep going on. It keeps going on. So this means that if I use that, if I compare them, right? If I compare these two equations together, like this, half kx square equals to half mv square. So these two halves should be cancelled out, right? And the x should be placed here. K, I know. Okay, right.
Sir, when will our next class start?
Um, Not after 9 or 10 minutes. Uh, I have
Okay.
a Zohar prayer, so inshallah after the Zohar prayer I will communicate the timings, right?
Okay.
So what if I plug the value of k here, 19 point I think 7, right? Yeah, 19.7.
Yes, sir.
So
19.7.
what if I take the maximum point here, 0.15, and the mass is 2 kilogram
Boss.
and the speed is unknown. I just need to check it whether we are getting the answer correct or not. So I need to make v square subject. So 19.7 times 0.15 square divided by 2.0.
Okay.
So
19.7
times
times
0.15
0.15.
square, remember.
Okay. Divide by 2, right?
Mm-hmm.
I got 0.221.
And 0.221.
221.
Okay, now put a square root on both sides.
Okay. Let me square root it.
Square root of the answer, 0.221.
Yeah.
Yes, what are you getting?
Sir, 0.470.
Yeah, we are getting the correct answer, 0.47 meter per second.
Okay. So that's it, right?
Yeah. So that was the part H, right? Now we're gonna
Yes, sir.
I think we have less than a minute, right? So
Oh, yeah, we have less than a minute.
we will discuss the rest of the questions in the next class, right?
Okay.
We will start tomorrow, okay? But the
Okay.
next class will be, the second class will be of maths, right?
Yes, sir. Today,
Okay.
right?
Sorry?
Today, right? Second class will be today.
Yeah, yeah, inshallah.
Okay.
Okay, Allah Hafiz, Assalamu alaikum.